Yeah, so today solve Roman to integer problem. So yeah, Roman numeral are represented by seven different symbols. Okay, I, V, X, L, C, D, and M. Okay, M for 1000, D for 500, C, and I for okay. Yeah. So for example, 2 is written 2, and in Roman numeral just two ones added together. Okay, 12 is written as a 12, which is simply x plus 2. Okay, fine. The number 27 is written as a 10, 10, 5, and 2, which is xx plus 5. Okay, fine. So like Roman numeral are usually written largest to smallest from left to right. However, the numeral for 4 is not 4. Okay. Instead, the number 4 is written as a 4 because the 1 is before the 5. We subtract it, making 4. The same principle applies to the number 9, which is written as a 9. There are 6 instances where subtraction is used. Divine. I can be placed before 5 and extend to make 4 and 9. Okay, and x can be placed in equal to 50 and c, so it will be 40 and 90. Similarly, c and d, it's make 400 and 900. Okay, so one interesting things here what he is telling, they are trying to tell me, like suppose like if smaller value will comes before a larger value, like here I is equal to 1, right? And this is a small value, and v is 5, right? So this is larger value. So when like smaller value will come before the larger value, so that time we'll subtract with a small value to larger value. So that's why here 5 minus 1 equal to 4. So similarly for this as well, x equal to 10 and l equal to 50. So 50 minus 10 equal to 40. Similarly for this as well, 100 minus x equal to 90. Okay, fine. So an example what is telling, is equal to 3, 3. So output is 3. Okay, fine. See, here is simple, no nothing extra things they are doing like this. So simple here, like we have to print this Roman number in integer value. So here 3 they have written 1, 2, 3. Sum we have to print it. Okay, sum. So 1 plus 1 plus 1 equal to 3. Yeah. So here as well, L, V, and 3. So here also like no smaller value it is there before this. So L equal to 50. Then again if we'll write downside uh, 5, then again we'll write downside 3. So it will be 58. Similarly for this as well, MCM, so M equal to 1000 and CM equal to 900 and XC equal to 90 and IV equal to 4. So X equal to 90, why? Because C equal to 100, right? And X is 10. Here this condition it is applied. Okay. So here 90. 100 minus X equal to 90 and 5 minus 1 equal to 4. And we are adding all those value and then we are printing those value on output. So what we'll do, uh, like for this we'll use hashmap, like with a what we call, with a single like we'll use greedy approach where like we'll try to add or subtract based on their value, then those value based on the character comparison. So like that we'll try to do. Okay. So uh, if you don't know what is greedy algorithm, I'll tell you what is greedy algorithm. So in greedy algorithm, what we are doing, so basically in greedy algorithm we are trying to make our decision step by step. In that, at each step we'll try to pick what looks like our best right now, like which one is higher kind of things. Okay, so suppose like I'll try to give you one example. So okay, in that in what we call in simplest way, I'll explain you. So suppose we have 87 rupees, okay, we have a 87 rupees. So in that, what are the minimum coins we have, like in 87, 50, 20, 10, 5 and 2, right? So in that greedy approach, what will do, it will pick first largest possible number. Okay, like it will pick 50 rupees, and 50 minus 87, it will be 37. So remaining we have a 37. Then it will pick 20 rupees, and 37 minus 20, it will be like remaining 17. So similarly it will pick 10 rupees, then 7 rupees will be remaining, then 5 rupees, 2 rupees will be remaining, and it will take 2 rupees, and 0 remaining, 0 rupees will be remaining. So how many steps we have done, how many coins we have? So we have a 50 rupees, 20 rupees, 10 rupees, 5 rupees and 2 rupees. So like how many steps we have done? 5 steps. So how many coins we have for reaching till 0? 5 coins, right? So yeah, so these are the what you call greedy approach, greedy algorithm, sorry. So yeah, so I'm going to uh, I'm going to create what we call, I'm going to create one uh, hash map where I'll try to store all the Roman numeral value here. Which one it is given? This one. So map character map equal to new hash map. So here we'll put all those values. So in map we'll put I is equal to 1. So similarly we'll do for all till m. So we'll do copy paste 4, 5, 6, 7 number we have. So v equal no v equal to 5, x equal to 10, and l equal to 50. Sorry, l equal to 50. C equal to 100, 500, D equal to, and M equal to 1000. Yeah. So after that, what I'll try to do, okay, we'll store like we have taken one variable. Visual result equal to 0. Here will return all those value. Return return here result result. So here we'll try to initialize all like a result value. Then we'll take one loop for int start from 0 into I equal to 0. I will be s dot length. Okay, then I plus plus. Then and those I'll try to get the value of a current Roman character. Okay, so we'll try to get those current Roman character value. So current Roman value. So equal to will get from map dot get is dot char charity of I. Then from here only we'll give one condition. We'll check like if those character it is there or like we'll check like if next character is exist or not. So for that we'll give what we'll give. Okay, and next character, so I plus 1 is less than s dot length. Okay, after that what I'll do, I, after that again I'll try to get the value of next a Roman character. Okay, like what I have taken here similarly, but like next. So I+1 I'll do. So I'll take like next int those next equal to map dot get is dot char 80 I+1. Then we'll get those value. Then again we have to check here only, because like if current number is smaller than next, then we'll try to subtract those value. This condition will check here, this one. Okay, so here like if current Roman value is less than this next Roman value. Okay, so then what I'll do here, we'll subtract in result. So result minus equal to current Roman. Then in else condition we'll add those value. Result plus equal to then this else condition will try to add again and will return those will add again those last character of those value. So result plus equal to current room, and here we'll return the final integer value. So let's see. Yeah. So uh, here like space complexity will be of 1 and time complexity also will be of it, because like map is size is fixed, so that's why space complexity will be of 1, because map size is 7 only, right? This one, so that is fixed. So yeah. Next Roman to integer. No, integer to Roman I'll solve. Integer to Roman. Seven different symbol represent. Yeah, this is also same what we have done in Roman to integer. In Roman to integer, what we are doing, we have a Roman, we have a Roman as a input, and in integer we are converting those Roman value to integer. Like in integer, like we are printing like 3. Here you will see 3. So in this integer to Roman, what we are going to do, I feel so. Like here, it's given integer value. We have to change on Roman value. Let's see. 7 different symbol represent Roman numeral with the following values. Okay. One. Similarly, same. Roman numeral are formed by appending the conversion of the decimal place value from highest to lowest. Okay. Converting a decimal place value into a Roman numeral has the following rules. If the value does not start with 4 or 9, select the symbol of maximal value that can be subtracted from the input. Fine. Appended that symbol to the result. Subtract its value and convert the remainder to the Roman numeral. Okay. If the values start with 4 or 9, use the subtractive from representing one symbol subtracted from the following symbol. For example, 4 is 1, less than 5, correct? So here this is okay. And 9, yeah, same thing. Here, so here also what we are going to do. Okay, I'll explain you. One, only the following subtractive from are used for 9. If suppose like okay, 9 pixel. So we'll like here also we'll use greedy approach only. So in greedy approach, what we are doing, we are going step by step. Like we are picking those value line by line. So we are we are dividing all value step by step. Like here we have to add it. Like we have to what we call we have to like we have to change like 3000, then we have to divide like 3000, then 749, then 49, then 40, then 9. So like that we have to add it. Okay, so let's see. Yeah, here it is. Only the power of x I x c m can be represented consecutively at most 3 times to represent multiple. Then you cannot append 5v 50l and 500t multiple times. If you need to append a symbol 4 times, use the subtractive form. Okay, fine. So given an integer, convert it into a Roman numeral. Okay, fine. So as I told, we have given 3000 value. So 3000 we have written in second line, 700 we'll write, and third line we'll write like 40, and in last line we'll write 9. So this one we have to convert on numeral form. Okay, so here you will see how 40 we got. Okay, like so excel. Okay, here like excel they have written, so l equal to 50, right? And x is 10. So we have separate, as we know, if lesser value will come, lesser value is less than bigger value, so that time we are subtracting a bigger value to lesser value, so that's why here 40. So similarly for this one as well, here like lesser value, here like greater value, so we are subtracting those value. 58. So L equal to 50, L equal to 50, V equal to 5, and 3 equal to 8. So we have added uh, in 3 line 58. Okay. Example 3, 1994. M for 1900 for CM. M means 1000, C is 100. So we have subtracted 1000 to minus 100, so 900. Similarly, so C 100, X 10, 90. We have subtracted 100 minus 10, so 90. 5 minus 1, so it is 4. So here also I'm going to use a greedy algorithm. Why? I'll tell you. Because like in Roman numeral, it's built by always taking the largest possible value. Okay, largest possible value. So that's why we have to take we have to choose greedy algorithm, like here, like once we'll take those biggest Roman symbol, this one biggest Roman symbol will take, so it will never it will it will no need to reconsider again kind of things. So yeah, so that's why it is a perfect approach. So here, like I'll try to create a Roman value in a descending order. So let's let's write how we have written on Roman to integer. So here also, like we'll try to corresponding those symbol first, right? Then we'll go the other things of string. 1000, 1000, 900 cm, 900 cm, 500 d, 400 cd, then c 100, c 100, c 100, then xc, xc 90, then L50, L50, then XL 40, then X10, then IX9, then 5, then 4, IV, then 1. So uh, after that, what I'll do, will take string builder of like string builder for build like for building our Roman like for storing those Roman value on string builder. So not text normal string string builder. So here we will store our value new string string builder will return our result as well. Then we take one for loop. After that, what I'll do? Start point I equal to 0. Then I is less than is dot length and I plus plus. Then what I'll do? I'll try to check like current value can be I'll try to check a current value. It can be subtracted from the num if it is a less than. So let's see. So while num is num is greater than equal to s of I. If it is a true, it will do. It will append those Roman symbol first. So result append symbols of I. Then here only will subtract those value equal to s of I. Let's see. Oh, sorry. We haven't mentioned this one hint. Hint. Suppose we have taken values equal to this is integer to Roman. Okay. So here like 1000 minus 900, 500, 400, 100, 90, 50, 40, 10, 9, 5, 4, 1. So we will write like values values Okay, we have to return final value as a numeral string. Use a numeral string value. We have to change. So we have to convert first while returning those value. So,
One more thing,
yeah.
Karina. So these are the commands are there, right? So I think in requirement section, so this is a good physical on this. So I talked to Karthik here regarding this. I think you have good knowledge. I think it's what I feel. Today you are talking to me like this. This is a really discussion. But if you give one second by next week, now, this will be you want to
Okay. गुड इवनिंग सक्षम भाई. सर मत बोला करो भाई. Yeah, so guys, that's it for today. Thank you.